Welcome to part 3 of the LemLib Pros tutorial. So in this part, we'll be doing the actual autonomous programming. This can be for your skills or for your 15-second autonomous at the start of a match. So first of all, I'll go through the competition template and what it actually does. So you could see this is where we've set up all of our devices already and our PID in the last video. And we can scroll down until we see initialize. So the code in here, it runs whenever you start running your program. So when you click run on your controller or on your brain, it'll run this code before everything else. So the default code here is just to start the screen and show the coordinates that it's currently at. We'll leave that because it's very useful for coding later. This is code that runs when your robot's disabled. So if you're plugged into field control and your robot gets disabled, it will run this code, but we normally don't use it. Same for this. It will run after your robot's connected to the field control, but we normally don't put anything here because we'll just use the normal initialize as it's easier. And then this is the autonomous. You can see our code from tuning PID last time, but this autonomous, basically it runs when you're doing autonomous skills, and it also runs at the start of every match for 15 seconds. And then once we go down here to OP control, once the 15 seconds is up, or if you run your program normally, then it'll run this code. So this code right here is just to control the controller and set up the drive base right now. But we'll be using this all of your controller controls and for your button mapping. Okay, so when you're programming your autonomous, since we have the odometry and the IMU installed, it'll actually output the coordinates to the screen. So if I run the program like this, you can see that after a while, the coordinates actually show up on screen. And if we move the robot, we'll be able to see it change. You can see that X is side to side, Y is up and down, and theta is the direction it's pointing. You could see I've set up a little obstacle course for the robot to complete. So this will take rotational moves, linear moves, and we'll also have to use the intake to pick up and put down the ball as well. So first, I'll tell you how to do the linear moves. So if we go to our robot here, so we're actually going to use the coordinates on the screen to program it, so we know where it needs to go because it's an exact coordinate. So there, I'm putting the robot to its starting position, and now I'm going to start the program. All right, the program started. You can now see the coordinates on the screen, and now I'm moving it to the coordinates that I want it to move to, and then I'll see what it says on the screen. So you can see that we moved 25 inches in the Y direction. So if I want to program that, I'll go back to my Visual Studio Code and I'll go to our autonomous, because remember we're programming autonomous, and then I'll put chassis dot move to point. This is gonna be our first linear command. So we have two linear commands, which is move to point and move to pose, which I'll tell you about later. But for now, we'll just put 0 for X because we did not move in the X direction, and 29.5 for Y because that's the coordinate that we just got just now. So for timeout, I'll put a time in milliseconds that the robot will take to reach that approximately. So we can tune this value later, but for now, I'll just set it as 1.5 seconds, which is 1,500. Because I think it'll take at least 1.5 seconds for the robot to reach that point. Okay, so now I'll build an upload and then we can test out what the program does when it runs. So I've uploaded the program, and now we can observe what it does when we run the program. And I've also marked out the locations that we want it to go to in this first tutorial. So you can see that it goes to the position we want, and next I'll show you what it looks like when we change X and Y. So to move in X and Y, I'm going to do the exact same thing, which is run the program on the robot, and then I'm going to use the coordinates that are already there to move to the other point. So I'm going to just move the robot by hand to the other point. And now we can look at the coordinates on screen. So the coordinates are 17.25 and 29.5. So we're going to go over and switch back to our code. And I'm going to change this to be 17.25 and 29.5. All right. And now we will build an upload and see what happens. we could see that it went a bit off course, but that's because we have all Omni wheels. So what I'm gonna try do is we're gonna switch back and I'll show you how to change the speed of the move. So I'm gonna add another comma here, and then we're gonna add a list for some parameters we want, but the only parameter we want right now is max speed. So I'll go dot max speed and then equals 64. Same as before, 127 being max. So I'm setting the speed around 50%, and we'll try build and upload this. So this is the 50% speed. So you can see now it's very accurate. We've reached our position, which is good. So now we're gonna try chain these two motions together. So we're gonna go back here. So the original code was chassis.move point 0 29.5, and since this is relative, we'll have to measure the location again. So because when we coded this one, we reset the position, so we're gonna have to run this code first, and then we're gonna have to find out what the coordinate is from the start position, from the same start position. So I'm gonna go ahead and do that now. You can see I'll move it back to the start, the first point, and then the second point. So the first point, the coordinates are still the same. And now the coordinates for second point have changed. So I'm going to put the new coordinates in right now. Now we should be able to run them together. So I'll add a delay between them so we could see that they are actually different moves. So I'll go pros, delay, and then let's say 2 seconds. And after we've added that delay, since we want it to wait for the first command to run before doing the second one, we're gonna set async to false, which just means that it will wait the full 1500 milliseconds before running the next two commands. And I'll also add some parameters which have nothing in it right now, but we have to add it so the syntax is correct. And now we're gonna try build and upload. Alright, so now we're gonna run our new improved code. So let's see if it has an improvement on the first one. You can see it moves perfectly to the first location, and now it moves perfectly to the second location. So you can see how we improved our code and how it works better now. So that's gonna be it for this video, because we've covered the main linear move, which is move to point, and in the next video we'll recover turning and more advanced turning commands like swing to heading. Okay guys, so in this part of the video, we're gonna do the rotational moves. So you can see I've added the rotational moves I want it to do in our obstacle course in red marker. So you can see that at 1, we want it to turn 90 degrees, of course, to pick up the ball later. And then I want it to spin 360 before it reaches 2. So now I'm gonna switch to our code and then I'll show you how to turn. So we have two main turning functions that I'm gonna use, which is turn to heading and swing to heading. So I'll tell you the difference later, but first we're gonna do turn to heading. So the command for this is chassis.turn to heading, and then theta is the amount of degrees you want it to turn. So if you want it to turn 90, put 90. If you want it to turn -90, put -90. So for this demonstration, I'm gonna use 90 because I want it to turn to face towards the ball, and then I think it won't take that long to turn, so I'll put 750. So now I'm gonna go try and run this code and see what the result is. So now I've uploaded the code that we just wrote, and it should turn 90 degrees, so it should face the ball. We'll see what it looks like when we run the code now. So you can see that it turned exactly 90 degrees. It hit the ball, but that's okay because our position linearly is wrong, but the rotation is good. So the next command I'm gonna teach is the swing to heading command, which is useful for tight corners like the one that the robot's in right now. So what it does is it only moves one side of the drive base, so the robot kind of swings off center a bit, and I'll show you what it is like versus turn to heading. So if we go into our program, and then we can comment this out. So we'll do chassis.swing to heading, and then if we go back to our robot right now, it needs to move 45 degrees. So we'll put theta to 45, And then the drive side, lock side would be right, because if we look at the robot here, when we're turning, we want the left side to move, but the right side not to move. I'll show you what it looks like now. So this allows us to turn on sharp corners, like I said. So in our code, I'm gonna put right here. And then our timeout is gonna be 750, because I think it can turn in 750 milliseconds. So now we're gonna build and upload the code, and we'll see what it looks like. So this is the swing to heading command, 45 degrees. You can see that turn on a very sharp angle, and I'll now show you what it looks like with turn to heading 45 degrees, and we can compare in a split screen. So to conclude, our swing to heading command is really useful for areas which you need to turn very sharply. For example, in high stakes last year, we didn't want to touch the autonomous line when going up to pick the middle rings. So we had to use swing to heading instead of turn to heading, so our wheels wouldn't cross the autonomous line on the other side. So in this next part, I'm going to show you how to manipulate the game objects. So you can see that a robot has an intake on it, and you can actually program this during autonomous. So our goal here is to get it to move to the different points by itself, and then it'll pick up the block and outtake it in the little tray at the top. So we'll go into the program now, and we'll program all of the movements as well as the intaking steps. Okay, so this is the code we wrote just now, and we're gonna test it. So it should just intake the ball. So we can see that our Y coordinate is a bit off, and our robot doesn't turn all the way, so we're gonna adjust the timeouts to be longer. So here, and then I'll change this timeout to 1000 instead, so that it turns to a proper angle. And then we're gonna change this move to point, so we're gonna add more on the X, so I'll go 8 instead, and now we can retest. Okay, so it's turning 180 degrees because I forgot to specify that it needs to move backwards. So that's another parameter. You could do comma, and then you could do dot forwards equals false. And now we can try run it again and see if it properly picks up the block this time. So we can see that our robot successfully picked up the block. So now we can continue on with our code. So we can save our progress working code. So now that we know that the code works, we can move on to our next bit, which is coding the second part of the auton routine. So we can go back to our instruction set, which says that we have to turn to theta 35. So we'll just go chassis dot turn to heading, then theta 35. Timeout would be 750. Good, and then we can add our speed limiter too, because we don't want it to go too fast because we don't have traction wheels. And then what that would do is it would basically just turn the bot to be able to go to the next move. So we would be here right now from the end of the last code, and we need to turn here. So once we've turned, we can actually move to the point that we want to spin 360 on. So chassis dot move to point, and then our point is x10 y50. And then our timeout is, let's say 1005, because that's quite a long move. And then we have our max speed again. And now let's test if that works. So we'll build and upload. All right, so this is the second part of our auton. Alright, so you can see it works pretty well right now. Hit the ball, but that's okay because I set up the ball wrong. But you can see that we've got to our position that we wanted. So now we can go back to our code, and then we want to spin 360. So LemLib won't actually let you set the coordinate to whatever you're at plus 360. So we have to turn 180 and then 180 again because it tries to find the most efficient path. So we'll just turn chassis.turn to heading, and then theta 225 because that's 35 plus 180. And then our timeout we can be 500, and then we need to turn again, chassis.turn to heading, and then we can have 405, that's 225 plus 180, and then our timeout should be 500. So you can see that now we'll turn 360, and let's test that really quick. you can now see that we've turned 360, and now we want to go to our second point. So we continue with the code. So you can see that our next point that we want to go to is 20.5 and y 53.5. So I'll go chassis dot move to point 20.5, and then y can be r 53.5, and then we'll set a timeout of 1 second. Okay, after that, we want to go straight so we can get to the finish. So we'll go chassis dot swing to heading because we don't want to go outside the white line, and then 455, and then as we wrote down, our lock side is right. So we have right, and then our timeout for this can be 500 because it's quite a short move, and then we'll add our max speed, of course. Add our max speed for the other ones too. Alright, and now we'll test this code and see if it works. Now we're gonna see how this new code performs. So you can see that it did all the right moves, and now we're in the right position. So now we're gonna try D-score. We're gonna follow the rest of our coordinates that we put down. So let's switch back to our code. So now we gotta move to the place where we're gonna outtake chassis point, and then our X, which is 22.5, and then our Y, which is 53.5. Okay, and now we have our timeout, which I'm gonna set to 750. There we go. And then we should outtake. We have to add our max speed as well as our node async. Okay, now we can control our intake. So intake motor.move -127. There we go. And now that should outtake. And then I'm gonna delay 500 seconds. And now I'll stop it so it doesn't running. Okay, and now at last step, we just need to move to our finish coordinate, which is our 5 and our y as 0, because going back to start, and then I'll set 2500 timeout, and that should be our code done. Let's upload and test it. So this should perform all of the functions that we've coded and pick up block, move it, and go to all the places that we want it to go to. Here, goes to point 1, and takes the block. There, and done. We can make it more accurate by adding max speed on the last bit, but I think that's pretty good, and I hope you now understand how to incorporate the different commands into your autonomous routine. In this part of the video, we're going to be coding our optical sensor. So optical sensor is used to detect different colors, because normally in a game you only want to pick up one color. So you can see on this robot, there's an optical sensor there attached in the intake. So it should detect the color of the ball that goes in. That's what it's set up to do right now. So if we look at it on the devices page, and then we click optical, you can see that there's a color value that's called the hue. So if I put a red ball in there, it'll change to red, as you can see. And the blue ball will change to blue. So depending on what the color of the object is, the hue will change. So today we're gonna code a simple function that basically, once it sees a change in color, it'll detect, and if it's blue, it'll raise the flag, but if it's red, it'll just eject it. So we're gonna go to our programming language. So we'll go to sensors. I'm at the top because we need to declare a new object. So that would be pros optical, and then I'll just name it my optical. So port 19, and now we'll go down to OP control. I set it up so that nothing's running, so we just have a blank area to write our code. So we're going to use an if statement because if a condition is met, we want it to do something, but if it's not met, we want it to do something else. So we'll go if my optical dot get hue, this gets numeric value that we saw in the brain earlier. So we actually need to figure out what hue is blue and which hue is red. I'm gonna go to optical, and then I'm gonna turn on the light to max. So the hue that I'm getting right now is 211. If I move it around a bit, I could see the lowest and the highest hue that the blue balls give. So we see it's around 190 to 220. So when we go to our code, we can put, if it's more than 190, and this is how you put and, my optical.getHue is less than 220. So this will detect balls in the blue color range. So if blue, run this code. So when we want it to outtake, but we want it to do it not instantly, because then we can't see which ball it's looking at. So I'll put a delay, so pros delay, and then delay 500 milliseconds. And then after that, I want to spin my intake motor in the opposite direction, because like I said, we want to eject the ball once it sees a color change. And I'm also gonna do my piston.extend, because like I said, we want the flag to raise when the blue ball is detected. And now we're gonna do red ball detection. So I'm gonna use else if, so I can detect the red balls. So I'll do my optical.getHue, and then I'm gonna do the same thing to see what counts as red. So I'm gonna put the red ball in. So you could see it's around 5 to 30 hue. So that's what I'm gonna put in our if statement. So if it's more than 5 and it's less than 30. So there we go. So now if red, run this code. So I'll do pros delay again. And then same, I want to inject the ball. So intake motor.move -127. But I don't want to extend the piston. So we'll leave it blank. And then if there's another color detected, it'll run this code. So I want to lower my piston, so my piston.retract, as well as intake motor.move 127, because I want it to intake, not outtake, when it's not detecting a color. So now I'm gonna build and upload this program, and we'll see what it looks like on the actual robot. Okay, so we've uploaded the program. The program's running now, and you can see that our intake is intaking, which is good. Alright, so our intake is running, and now I'm gonna try put in one blue ball, and we'll see what it does. You can see that it worked, so it ejected the blue ball, and also put the flag up. Let's try put in a red ball now. So you can see that it ejected the ball, but it didn't put the flag up, which means our code is working. So now your bot can tell the difference between a blue ball and a red ball. So the last sensor that I want to cover is the distance sensor. You can see I have one here. So what the distance sensor is, it tracks the distance between any object that it can see and itself. So it'll tell you the distance between it in millimeters. I've selected it here on the brain. You can see that it changes as I move my hand back and forth. So for this demonstration, I'm gonna code it so that if an object's closer than 200 millimeters, it'll deploy the flag. So we have to go into our Visual Studio first, and we can go to our sensors. So we need to add the distance sensor object. So pros, distance, and then also my distance, and then it's on port 7, so I'm putting 7. And now we can go to our OP control. Same thing, there's nothing in here already. So I'm just gonna put a simple if statement, because we have a condition, which is if the object's closer than 200 millimeters. So if my distance is .get distance, so this will give you the distance in millimeters, is less than 200, then I will get my piston.extend, because when it's closer than 200, it'll extend because the distance is less than 200. So isn't closer than 200, then I'm gonna get my piston to retract, so that it retracts when it doesn't see an object within 200. So now I'm gonna build and upload, and we can see what this looks like on the actual brain. Okay, so now I've uploaded the program and we're gonna see what it looks like when we run it on the controller. So you can see now that our flag is down because there's nothing within 200, but if I put my hand here, it'll extend. And if I take it out, it'll retract. So now you can see how the distance sensor works, and it can detect objects by putting the flag up.